So determinants அப்படினால it is associated with the matrix. Okay, so matrixக்கு ஒரு value கொடுக்கிறது தான் determinant. Okay, but இதுல வந்து only square matrix can be given value in the form of determinant. Okay, so to every square matrix we can associate a number. Okay, that is called the determinant of the matrix. So இப்போ வந்துட்டு determinant of matrix of order 1 இருந்துச்சுன்னா ஒரே எலிமெண்ட் தான் இருக்கும் அதுல. So அதுதான் அதோட வேல்யூ, determinant வேல்யூ. So whatever is the matrix element itself. If suppose it is a matrix of order 2, so then this is how we calculate the determinant value. So we take the two diagonals, the leading diagonal A11 into A22 minus the other diagonal A21 into A12. So that is your value of determinant. Right. So for example, if there is a determinant 1, 2, 3, 4, okay, so we calculate its value as 1 into 4 minus 2 into 3. That is, it evaluates to minus 2. Otherwise, if the other matrix minus 5, 2, minus 2, 0, so the determinant corresponding determinant will be minus 5 into 0 minus minus 2 into minus 2. So it evaluates to 4. So this is how you calculate the value of determinant. Okay. So I think you will have read about it. So I don't want to spend a lot of time on that. Okay. So அடுத்தது இப்போ third order matrix நம்ம போகும்போது there is a concept of minor and cofactor. Okay, so other ways பண்ணி தான் determinant value கண்டுபிடிக்க முடியும். அதனால minor is applicable for each and every element. So any element in a matrix if you take அதோட minor வந்து it is the value of the subdeterminant, okay, formed by deleting the row and column where that element whatever element we picked up. So aij என்கிற எலிமெண்ட் நம்ம எடுத்துக்கிட்டோம்னா அதோட கோஃபேக்டர் என்ன அப்படின்னா the ith row in jth column delete பண்ணிடணும். So it reduced the matrix of one order lower, determinant of one order lower. So அந்த determinant value தான் cofactor minor அப்படின்னு சொல்றோம். Okay, cofactor அப்படிங்கிறது it is a signed minor. So that means we take that A11 the first element as positive, அதுக்கப்புறம் next element will be negative, அதுக்கு அடுத்தது திருப்பி positive, அடுத்தது negative, d alternate போயிட்டு இருக்கும். So that will be minus 1 to the power of I plus j. Okay, so you multiply minor value by minus 1 to the power of I plus j, you get the cofactor. Okay. So now determinant of matrix of order 3 and above will be like this. Okay, so if this is a matrix A B C D E F G H I, its determinant is calculated as A into அதோட cofactor. Okay, A into cofactor என்ன இந்த A இருக்கிற அந்த ரோவையும் காலமையும் delete பண்ணிடுறோம். அப்போ பாக்கி இருக்கிறது E F H I. So A into this smaller determinant. Okay, அடுத்தது minus போடுறோம் because cofactor we saw that it is minus 1 to the power of I plus j. So அதனால minus அடுத்தது second element B போட்டுக்கிறோம். B into, so அப்போ இந்த B இருக்கிற ரோவையும் காலத்தையும் நம்ம delete பண்ணிட்டோம்னா you get D into I, sorry, DFGI will remain இல்லையா? So DFGI அப்படின்னு போட்டுக்கலாம். So அடுத்தது திருப்பி sign will become plus now. So plus C into அந்த row column delete பண்ணிட்டு DEGH வரும். So this is how you determine the value of determinant of So you can do it either cofactor. Now plus plus cofactor the sign of any matrix A equal to the sum of the product of the elements of any row or column with their corresponding cofactors. Okay, so you usually take the top first row. So every element into its cofactor, next element into its cofactor, next element into its cofactor. So that is how you determine the value of a determinant. இப்போ ஒரு எக்ஸாம்பிள் எடுத்துக்கலாம். So evaluate this determinant 1 minus 3 2 4 minus 1 2 3 5 and 2. So it will be 1 into, so we take out that row and column, so what remains is minus 1 2 5 2, then minus, okay, so then take the next element which is minus 3 into, take out that row and column, you get 4 2 3 2. Again, next you put plus 2 into, because 2 is the third element in the first row. So now you cut out that row and column where the 2 lines. So whatever remains 4 minus 1 3 and 5. So evaluate that, so you get the value of the determinant. Okay. So this is how you calculate the value of the determinant. So இது ஒரு determinant of third order க்கு மட்டும் ஒரு quick method இருக்கு to determine its value. அது பேரு Sarah's rule அப்படினு பேரு. That's because it was invented by one mathematician called Sarah's. So according to that rule என்ன பண்றோம், இப்போ இந்த A11 A12 A13 A21 A22 A23 A31 A32 A33 இந்த determinant value கண்டுபிடிக்கணும் அப்படினா, so we add the first row, first column and the second column. Okay, as you add them like shown in the picture. So then you simply take the product from top to bottom like this. A11 A11 into A22 into A33 plus A12 into A23 into A31 plus A13 into A21 into A32. So the red lines are clear. So you multiply those three elements. So you add them up. So that is one value. Adhe mari blue lines are clear. So from bottom to top, A31 into 22 into A13. So the blue lines lo ulla three products here add pannunga. So you then subtract the second from the first. Okay. So you add all the plus, add the minus, subtract the minus value from the plus value. So that then you get the value of the determinant. It is slightly easier, but it is applicable only for matrix of third order. Okay. So there is an example. Okay. So the given determinant is 5 0 2 1 3 4 minus 1 1 0. So you add the two columns, first column and second column by its side. So 5 1 minus 1 0 3 1. So you multiply like I showed in the previous page. So 5 into 3 into 0, 0 into 4 into minus 1, 2 into 1 into 1. Okay, so those are all the pluses. Minus 1 into 3 into 2. Like shown in this example, you can see that. Okay, so it is slightly quicker to calculate like this, instead of the original method of element into its cofactor. Okay. Move on. மெயினா என்னன்னா இந்த ரொம்ப முக்கியம். Most of your determinant problems will be using these properties, and so without there was slight interruption. உங்களுக்கு கேட்க முடியுது இல்லையா everybody?
Yes sir.
Okay, nice. Just wanted to make sure the disturbance in between. சரி, இப்போ first property என்ன? The determinant of a matrix remains unaltered if the rows are changed columns and columns into rows. ஒரு டிட்டர்மினன்ட் எடுத்துக்கிட்டு அதோட வேல்யூ கொடுக்கணும், அதை டிரான்ஸ்போஸ் பண்ணிட்டு அதோட டிட்டர்மினன்ட் வேல்யூ கண்டுபிடிக்கிறதும் இட் வில் பி தி சேம். இது வெரி ஆப்வியஸ். ஏன்னா நம்ம we have seen that the determinant is calculated by a cofactor into its any element into its cofactor அப்படின்னு பார்த்தோம். ஸோ ஃபர்ஸ்ட் ரோ எடுக்கிறதுல நான் ஃபர்ஸ்ட் காலம் எடுத்துட்டாலும் it is still going to work. ஸோ அதனால even if you transpose, what do? We change rows to columns. Yeah. So whether you take row wise or column wise, you will get the same result. So the determinant will not change if you transpose it. Right? That is rule number 1. Now, this is very important. Okay, if any two rows or columns of a determinant are interchanged, then the determinant changes in sign, but its absolute value remains unaltered. Okay, so we can do many such interchanges. So ஒரு வாட்டி நம்ம ஒரு row ஒரு அதை interchange பண்றது, அது வாட்டி பண்ணா அதோட sign change ஆகும். So ரெண்டு வாட்டி பண்ணா it's going to change 2 times. That means and so on. Okay, so it will become -1 to, so if you make n interchanges, that is your property. Was identical, then its determinant is 0. This is very, very important. Okay, ரெண்டு ரோ சேமா இருந்துச்சு அப்படின்னா, ஃபார் எக்ஸாம்பிள் எடுத்துங்க, a1 b1 c1, a2 b2 c2, திருப்பி a2 b2 c2 அப்படின்னு இருக்கு. So if two rows are identical here, okay, so if row 2 and row 3 இந்த மாதிரி இருந்துச்சுன்னா, we don't have to calculate. We can straight away say that this determinant is going to be 0. Okay, at the end, if you interchange the second and third row, you're going to get this. So எந்த the sign change ஆனாலும் it will be this equal, only for 0. Even if you change the sign, it will be the same. If it is any other value, if you change the sign and the value, it cannot remain the same. Yeah, so because in this case, since even when we interchange two rows, its value remains the same, it has to be 0. இப்போ அடுத்தது, if a row or a column of a matrix A is a scalar multiple of another row or column, then also its determinant is 0. ஏன்னா நம்ம இன்னொரு ப்ராப்பர்ட்டி பார்ப்போம். இப்போ ஒரு row if it is multiplied by a scalar, like instead of the first row a1 b1 c1, suppose it is 2a1 2b1 2c1, you can take out the 2 and write it as 2 வெளியில போட்டுட்டு a1 b1 c1 அப்படின்னு எழுதலாம். அதனால so any then the two rows will become equal. இப்போ ஒரு row வந்து is a scalar multiple of another row, we can take out that scalar and make the two rows equal. So அதனால it will become 0. One minute. So I think I got it back now. So next property என்னன்னாக்க, if each element in a row or a column of a matrix is multiplied by a scalar k, then the determinant is multiplied by the same scalar k. So இப்போ இதுல வந்து k a1 k b1 k c1 இருக்கு பாத்தீங்களா, second determinant. So அதுல வந்து we can take out k and then it will become determinant a1 equal to k into a அப்படின்னு ஆயிடும். So that's what it says. No, I already not சொன்னேன் some time back. So if you see something common in a row or a column, we can take it out. Okay. Okay. This next property. Next property என்னன்னா, இப்போ to take any row or a column, in this case let's take the first column, and we write it as a1 plus m1, a2 plus m2, a3 plus m3 அப்படின்னு இருந்ததுன்னா, so that is equivalent to writing as two determinants like this. Okay, so a1 b1 c1, a2 b2 c2, இந்த மாதிரி we can these two are equivalent. So next property, if to each element of any row or column, the equi multiples of the corresponding entries of one or more rows are added or subtracted, then the value of the determinant remains unchanged. Okay. So I want to explain a bit. In the property என்ன சொல்லுதுன்னா, you take any row and you can modify it as that row plus k into another row. Okay, so then the determinant doesn't change. Okay, so because நம்ம already பார்த்தோம், if you put it as the first row plus k into second row, we can write it as two determinants, right? One is the original determinant plus second will be simply k into second row அப்புறம் second row அப்படி இருக்கும், which will be 0. So அதனால the determinant value doesn't change. Okay. Okay. So, in the properties of determinants, so how it is going to help us in solving the problems, solving the, determining the value of determinants. We'll see some examples now. Because this is your problem. Determine the value of a equal to secant square theta tan square theta 1 tan square theta secant square theta minus 1 38 36 2 அப்படி இருக்கு. இப்போ we know that secant square theta is equal to tan square theta plus 1 trigonometryல நம்ம படிச்சிருக்கோம் இல்லையா? So அதனால our goal should be to see if we can bring two columns or rows as equal, then we can immediately say its value is 0 இல்லையா? அதே மாதிரி இல்லனா one row பூரா if you can bring it as a scalar multiple of something else, then scalar can be taken out. அந்த மாதிரி நம்ம simplify பண்ண முடியும். So we should try to manipulate so that we either try to take out some scalar or you try to equate two rows or two columns. So அதுதான் நம்ம அப்படி பண்ணி தான் நம்ம இதை சால்வ் பண்ணோம். இப்போ நீங்க இதை பார்த்தீங்கன்னா secant square theta equal to tan square theta plus 1 அப்படிங்கிறதுனால we can do one transformation without changing the value of determinant. We can write this determinant as second column equal to second column plus third column. அப்படி போட்டீங்கன்னா so this every element will become tan square theta plus 1 secant square theta minus 1. And I will show it as C2 plus C3 side line. Okay, அப்ப oh god, again the network is bad. Looks like there is some problem in the internet. So I'm going to change the network to my phone. Okay, just give me a minute. So இப்போ பாத்தீங்கன்னா the first column we didn't do anything, second column only we changed like this. So இப்போ வந்து tan square theta plus 1 is equal to secant square theta, secant theta minus 1 equal to tan square theta, 36 plus 2 equal to 38. ఇప్పుడు when we do this transformation, we have made first column equal to second column. So then we can say that its value is 0. So without actually using the cofactor and all that, long multiplications, we are able to say that this determinant value is 0. Okay, so this is the power of those properties. Okay, so and the properties of the நிறைய problems வரும் உங்களுக்கு. So we will do one more example now. Hope you understood these properties and this example, right? All of you. ஏதாச்சும் question இருந்தா please கேளுங்க.
No doubt, sir.
Good. இப்போ இது கொஞ்சம் நீங்க think பண்ணி பாருங்க எப்படி போடலாம். There is a determinant as given here, b plus c, bc, b square, c square, c plus a, ca, c square, a square, a plus b, ab, a square, b square. இப்படி இருக்கு. So we want to prove that this is equal to 0. Anybody has got any idea? Please let me know. கொஞ்சம் திங்க் பண்ணி பாருங்க.
R1 gives R1 plus R2 plus R3, sir.
R1 equal to R1 plus R2 plus R3. Now that won't help in this case. Okay. But since நம்ம 0 னு prove பண்ணோம் அப்படின்னா we have to make two rows or two columns as equal, right? நான் சொன்னேன் இல்லையா, we can try to take out a scalar and then that row or column will become 1 1 1. Similarly we can try the same for another row or column also. ஏன்னா பாருங்க இந்த எக்ஸாம்பிள் பாருங்க. First what we do, we multiply the R1 by A and R2 by B, R3 by C. பண்ணேன்னா middle terms எல்லாம் நம்ம ABC 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 ன்னு கொண்டு வந்துட முடியும். It is very similar to like what we do in simultaneous equations. We try to bring the terms equal so that they can be subtracted and பண்றோம் இல்லையா. So the same thing only we do here. Okay, so they are like simultaneous equations. So how can we make the second column BC CA AB equal பண்ணனும் அப்படின்னா first இத வந்து A ஆல மல்டிப்ளை பண்ணனும், செகண்ட் வந்து B ஆல மல்டிப்ளை பண்ணனும், third C ஆல மல்டிப்ளை பண்ணலாம். So நம்ம அப்படி மல்டிப்ளை பண்ணும்போது என்ன பண்ணனும், since we have multiplied by A B and C, we have to take out that A, 1 by A 1 by B 1 by C நம்ம வெளியில போட்டுறோம். So this can be written as 1 by ABC into இப்படி போட்டுக்கலாம். First row A ஆல, second row B ஆல, third row C ஆல. Okay, so R1 is transformed as R1 into A, R2 is transformed as R2 into B, R3 equal to R3 into C. இப்ப பாத்தீங்கன்னா ABC 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 அப்படின்னு வந்துச்சு பாருங்க. So this now we can take out a ABC and make it as 1 1 1, right? Similarly we'll try to make this other column also. We'll see how to do that. Something keeps going wrong. One second. Okay. One minute. Okay. Right. இப்போ so we write it as since we had taken out, we can I have to go back to the previous page now. இதுல பாத்தீங்கன்னா இந்த ABC 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 ஆயிடுச்சு செகண்ட் காலம். தேர்ட் காலம் ஆல்சோ AB square C square A square B C square A square B square C அப்படின்னு ஆயிடுச்சு. இப்போ இதுலயும் ஒரு ABC வெளில எடுக்கலாம், இதுலயும் ஒரு ABC வெளில எடுக்கலாம். ஸோ ABC ஸ்கொயர் நம்ம வெளில எடுத்துறோம். ஓகே, அப்போ என்ன ஆயிடுது, we take out ABC square and we write it as the first column doesn't change, A into B plus C, B into C plus A, C into A plus B அப்படியே இருக்கு. Second column, since you have taken out ABC, 1 1 1 அப்படியே ஆயிடும். Third column also, since you have taken out ABC, it will become BC, AC, AB. இப்போ நீங்கள் பார்த்தீங்கன்னா இந்த BC இது வந்து AB plus AC அதோட இந்த BC ஆட் பண்ணலாம். இந்த BC plus BA அதோட இந்த AC ஆட் பண்ணலாம். அப்படி பண்ணும்போது இந்த ஃபர்ஸ்ட் காலமை நம்ம எல்லா டேர்மையும் ஈக்குவலாக பண்ண முடியும். ஓகேவா? So next step what we do, C1 is transformed to C1 plus C3. அப்போ என்ன ஆயிடுது, இந்த காலம் AB plus AC plus BC, BC plus AB plus AC, AC plus BC plus AB. Other columns don't change. Okay. இப்போ பார்த்தீங்கன்னா இது மூணு ஈக்குவலாக வந்துருச்சு பாருங்க. Right? So we can take out and make it as 1 1 1. So when we take out, we have to write it outside. Okay, ABC divided by AB plus AC plus BC into 1 1 1 1 1 1 BC AC AB. So since two columns are now equal, the determinant value is 0. So 0 into some other value, it will still remain 0. So therefore we have solved the problem. Okay. So in the Marida, with some multiplication and some simple manipulations, we have to prove determine the value of determinant or prove its value as 0. Okay. Okay. So we'll do more problems, but I am keeping it for the next class. So today I just wanted to explain the concepts. Okay. So another important concept in determinant is the factor theorem. Okay. So factor theorem அப்படிங்கிறது என்னன்னா, நம்ம நார்மல் எக்ஸ்பிரஷன் இருக்கு இல்லையா, any expression, if you substitute, suppose there is a function of x and we substitute x equal to 2 and then it becomes it evaluates to 0, then we say that x minus 2 is a factor. Right? If you put x equal to a and it evaluates to 0, then x minus a is a factor of that expression. So normally in algebra we would have seen that. So the same thing is applicable for determinants also. So if there is a sometimes the determinant will not be like numbers. There will be given in terms of functions of polynomial in x. Okay. So appa vandu suppose we substitute x equal to a and then the determinant becomes 0, then x minus a is a factor of the determinant. Okay. So in the theorem use பண்ணி நம்ம ஒரு determinant will be if it is having x and all, and the determinant evaluate பண்ண பெரிய எக்ஸ்பிரஷன் வரும் x ல, அதை நம்ம ஃபேக்டரைஸ் பண்ணுவோம். usually we need to factorize to simplify இல்லையா. So அதை வந்து நம்ம ஈஸியா பண்ண முடியும் இந்த ஃபேக்டர் தியரத்தை வச்சு. Just by substituting and verifying we can factorize the determinant. In the rules பாத்துக்கங்க, if you substitute b for a in a determinant, any two of its rows or columns become identical, then by factor theorem a minus b is a factor of that determinant. Okay, so when we substitute, if two columns become identical, then the value is 0 இல்லையா. So அதனால by factor theorem a minus b is a factor of that determinant. இப்போ நம்ம இந்த மாதிரி சப்ஸ்டிட்யூட் பண்ணும்போது instead of two rows or column become identical, we are able to make 3 rows or columns as identical. Then x minus a square is a factor, because 3 rows we are able are becoming equal. Then 3 minus 1, that is 2. So a minus b the whole square, that is the factor. So if r rows are identical in a determinant, when we put x equal to a, then x minus a to the power of r minus 1 is the factor of that determinant. There is one more concept called cyclic symmetric matrices. It's applicable for square matrix. Square matrix or its determinant is said to be in cyclic symmetric form if each row is obtained by from the first row by changing the variables cyclically. Okay. So இப்போ first row என்ன இருக்கு 1 x square x cube அப்படின்னு இருக்கு. அதுல x க்கு பதிலா நம்ம y substitute பண்ணோம்னா it becomes 1 y square y cube. Then if substitute z it becomes 1 z square z cube. இந்த மாதிரி இருக்கிறது cyclic symmetric matrix or return matrix. Because there are some properties which can be applied for cyclic symmetric matrices. If the determinant is in cyclic symmetric form, and if m is the difference between the degree of the product of the factors and the degree of the product of the leading diagonal, and m is 0, then the required factor is a constant k. It's கொஞ்சம் complicated. I will explain with an example. இப்போ இந்த மாதிரி ஒரு டிட்டர்மினன்ட் இருக்கு x plus 1 3 5 2 x plus 2 5 2 3 x plus 4 இப்படி இருக்குன்னு வச்சுக்கலாம். இப்போ we have to see எப்படி நம்ம ரெண்டு ரோவை ஈக்குவலா பண்ண முடியும் அப்படிதான் நம்ம பார்க்கணும் இல்லையா. x plus 1 இருக்கு, இங்க 2 இருக்கு, உடனே நம்ம x equal to 1 ன்னு போட்டா okay it becomes equal இல்லையா. So that's what we should try. So you put x equal to 1, immediately it becomes 2 3 5 2 3 5 2 3 5. So all the three rows become identical when you put x equal to 1. So அப்ப நம்ம என்ன கன்க்ளூட் பண்ணலாம்? So for this determinant x minus 1 whole square is a factor, right? That's what the factor theorem says. When you put x equal to 1, the determinant vanishes. Not only vanishes, not just 2 rows become equal, but 3 rows become equal. The square becomes a factor. Since all 3 rows are identical for x equal to 1, by factor theorem, we can say that x minus 1 the whole square is a factor of the determinant. Let's take another example. So there is a determinant like this 1 1 1 x y z x square y square z square. This is the cyclic symmetric matrix. Okay. So now we have to show that it evaluates to x minus y into y minus z into z minus x. So அப்ப நம்ம என்ன பண்ணோம்? We simply put x equal to y and see. Okay, what is the value of the determinant? If you can prove that when you put x equal to y, this determinant becomes 0, then x minus y is a factor, right? Then you try to put y equal to z and it becomes 0, then y minus z is a factor. So that is your factor theorem. Yeah. So by substituting, we can verify and we can verify whether x minus y, y minus z and z minus x are factors. Substitute பண்ணி பாருங்க நீங்க. It's a very simple thing to do. Okay, so if you put x equal to y, the first column will become 1 y y square. Second column is already 1 y y square. Yeah, so that value of the determinant is 0. So when x equal to y, c1 become equal to c2. So therefore x minus y is a factor, right? Same way we can prove that y minus z and z minus x are factors. So you put y equal to z and see what happens. So the second column will become 1 z z square. So it will be equal to the third column. So we can conclude that y minus z is a factor. Similarly, z minus x is a factor. It's a cyclic symmetrical. Another one that normally the others will also be true. So we are now determined that x minus y, y minus z and z minus x are factors. Okay, but that doesn't tell us that there are no other factors. We cannot say that there are only these three factors. Yeah, so we have to see what else is there. These three are factors, okay, right? But what else can be there? And அதுக்கு தான் நம்ம ஒரு முன்னால ஒரு ரூல் பார்த்தோம் இல்லையா, இந்த cyclic symmetric இந்த ரூல் அப்பதான் அங்க அப்ளை ஆகும். Okay, so I'll explain what it is now in this example. So இப்போ நம்ம என்ன, now we proved that these are factors. So what are the remaining factors? அதுக்கு தான் the degree of the known factors என்ன அப்படின்னு பார்க்கணும். So degree of the known factors என்ன, மூணு factor இருக்கு. இது மூணுத்தையும் நம்ம multiply பண்ணா the degree is going to be 3, right? So you'll get an expression. So degree of that expression will be 3, right? Because ஒரு factorம் first degreeல இருக்கிறதுனால மூணுத்தையும் multiply பண்ணும்போது we get the known factors is 3. அடுத்தது என்ன பண்ணும், we have to take the leading diagonal in the matrix and see what is the degree of that. So you take the leading diagonal, which is 1y and z square, multiply the 3, 1 into y into z square, you get y z square. So what is the order of that? That is again y z square is of the order of 3. So the leading diagonal is also of third order. So we got three factors. So that also the multiplication of the three factors, அதுவும் third order அப்படிங்கிறதுனால the remaining factor can be only a constant, right? That is very logical, right? Already it is in third order. So if you put x or y in the fourth factor, then its order will become 4. Yeah, but in this determinant, the maximum order you will get is only 3. So அதனால that we still don't say that it is 1. We can only say that it is k, some constant, right? So we write it as a equal to k into x minus y into y minus z into z minus a. And now we have to determine the value of k. Right? So how do we do that? So how we do that is, we can choose some values for x, y, z at random. Whatever, some simple values, whatever will be easy for us. We can choose some values for x, y, z and substitute. So we will get one value on the LHS, one value on the RHS. So based on that, we can determine the value of k. So what I'm choosing, x equal to 0, y equal to 2, z equal to 3. So the values you should choose should be such that that determinant that doesn't become 0. Okay, for example, if you take x equal to 1, y equal to 1, z equal to 1, it will become 0. If in the become 0, in the become 0, it doesn't give you the value of k. And we have to choose values so that it doesn't become 0. அதனால தான் இந்த மாதிரி எடுத்துட்டேன். x equal to 0, y equal to 2, z equal to 3 அப்படின்னு எடுத்துட்டோம்னா simply substitute 111 023 049 is equal to k into x minus y, it is 0 minus 2 and y minus z and z minus x. But it becomes this. இதை நம்ம இந்த டெட்டர்மினன்ட் எவாலுவேட் பண்ணும்போது எப்படி பண்ணணும், இப்போ நம்ம ரோ மெத்தட் யூஸ் பண்ணக்கூடாது, இப்போ நம்ம காலம் மெத்தட் யூஸ் பண்ணா இந்த ரெண்டு காலத்துல இந்த ஃபர்ஸ்ட் காலம் எடுத்துக்கிட்டீங்கன்னா ரெண்டு இது 0 இருக்கு பார்த்தீங்களா, அதனால we'll have to use the column method. So that means take the first element, அதோட cofactor, first காலத்துல second element ஓட cofactor, whatever it is, it will become 0 because this is 0. Similarly third will also be 0. So we have to only evaluate the first one. So 1 into, so what is the cofactor? 2 into 9 minus 3 into 4. So that becomes 6, right? So in the side left side k into x minus y into y minus z into z minus, if you substitute the same thing, equal to 0, y equal to 2, z equal to 3, it becomes this is 6k. So this one is 6. So 6k equal to 6. So that is how we determine that k equal to 1. Okay. So suppose the leading diagonal didn't evaluate to the same degree, so suppose there is அதுக்கு தான் இப்பதான் இந்த rule யூஸ் பண்ணாங்க. If m is 0, that is the degree difference in the degree, then the required factor is a constant. But if the difference is 1, then the required factor is k into a plus b plus c. If m equal to 2, then the required factor is k into a square plus b square plus c square plus l into ab plus bc plus c. So all kind of elements of second order எடுத்துக்கணும். The squares are a b b c c a. So அதனால we have to take it like this, k into this plus l into this. So in the case ரொம்ப சிம்பிளா போச்சு. There may be other complicated more complex cases. அப்ப நம்ம இந்த மாதிரி எடுத்துட்டு still we have to determine the value of k and in this case second case only k, third case we have to determine the value of k and l. Okay, so now that's how we prove. Right. So இது வரலையும் that factor theorem clear?
Yes, sir.
Okay, fine. Now product of two determinants. Okay. So இப்போ நம்ம ரெண்டு மேட்ரிக்ஸ் நம்ம மல்டிப்ளை பண்ணும்போது ரோ ரூல் அதுதான் நம்ம ஃபாலோ பண்ணோம். We have to take the first row and multiply by first column, then that becomes the resultant matrixல 1 1 element. அதே மாதிரி நம்ம பண்ணுவோம் இல்லையா? when I multiply two matrices we will use row by column rule அப்படின்னு. But in the case of determinant, we saw that a determinant doesn't change even when you transpose that matrix. So a determinant of a equal to determinant of a transpose. So adunala, so we can either use row by column method or row by row method or column by column method. So we can use multiple methods here. Okay. ரெண்டாவது, if ரெண்டு square matrices இருந்ததுன்னா then the determinant of AB equal to determinant A into determinant B. Okay. The important thing is in matrices AB is not equal to BA in general. AB equal to BA in case of determinants. Okay. In matrices it is not true, but in determinants it is always true. AB equal to BA. So we'll take an example. I've taken simple determinants 1 2 3 4 no 2 3 4 5. Because we want to multiply these two determinants. We can use multiple methods like we saw. First method we can simply take is you are multiplying two determinants. First determine the value of A, then B, then you can multiply. Okay, so that means here det A and det B we are simply doing. Okay, det A is equal to -2, det B equal to -2, so det A into det B equal to -2 into -2, which is 4. This is one method. Okay. Let's go to the second method. We multiply the determinants and then we do that AB. அதுக்கப்புறம் then we evaluate it. அது எப்படின்னா இந்த மேட்ரிக்ஸ் மாதிரி கன்சிடர் பண்றோம் இல்லையா? இது ஒரு மேட்ரிக்ஸ், இது ஒரு மேட்ரிக்ஸ். அப்ப மேட்ரிக்ஸ் மல்டிப்ளிகேஷன் மாதிரி நம்ம பண்றோம். ஸோ இந்த மாதிரி மல்டிப்ளை பண்ணோம்னா அப்ப வந்து we saw that either we can do row by column or row by row or column by column or column by row. ஸோ என்ன வேணா 4 ஆப்ஷன் நம்ம பார்த்தோம். ஸோ let us take row by column method like matrix. அப்படி பண்ணா என்ன ஆகும்? ஸோ இதை மல்டிப்ளை பண்ணும்போது the first element we write as 1 into 2 plus 2 into 4, which is 10. This element we write as 1 into 3 plus 2 into 5, that is 13, and so on. So we multiply the two matrices like this. Adukapram we evaluate that determinant as 10 into 29 minus 13 into 22. So we get the same answer. It's 4. Row by row method அப்படின்னா அப்போ we take the first row and first row in the B also. That means 1 into 2 plus 2 into 3. Okay, so that is the 8. இப்போ இது வந்து first row into second row. அப்போ 1 into 4, 2 into 5. அது 14. Right? அடுத்தது வந்து second row into first row. That is 3 into 2 plus 4 into 3. அது 18. கடைசி இது வந்து second row into second row. That is 3 into 4, 4 into 5. It is 32. So we multiply the determinants like this. Okay, and then evaluate 8 into 32 minus 18 into 14. So it again becomes 4. So we can multiply two determinants by multiple approaches. Okay. There is something called a cofactor determinant. Then for a given determinant, we can form another determinant in which each element is the corresponding cofactor of the original determinant. அந்த மாதிரி determinant பேர் cofactor determinant அப்படின்றது. So for example, there is a determinant 1, 2, 3, 4, 5, 6, 7, 8, 9. We form another determinant like this. So 1 இருக்கிற இடத்துல 1 ஓட cofactor value போடுறோம். What is the cofactor value? 1 ஓட cofactor value 5 into 9 minus 8 into 6. That we put here. So 2 இருக்கிற இடத்துல find out its cofactor and put it. So you get this determinant. So this is called the cofactor determinant of the original determinant. But the sum of product of the elements of any row with their corresponding cofactors is the value of the determinant. So we know that the value of the determinant is take the first row and its corresponding cofactors. Yeah, so 1 into minus 3, 2 into 6, 3 into minus 3. So that is going to be the value of the determinant. So if you have the cofactor determinant, it is very easy to determine the value of the determinant. Another property enna, if elements of a row or column are multiplied with corresponding cofactors of any other row, then their sum is 0. Okay. So if you take the first row and take the second row cofactors second row, other put multiply panninga and always it will become 0. Okay. So another application of this determinant is your area of triangle. Suppose we have the coordinates of the three triangles, of the coordinates of the three vertices of the triangle. So they are x1, y1, x2, y2, x3, y3. Then its area is given by this determinant. Okay, first half into first column is x1, x2, x3. Second column is y2, y1, y2, y3. Third column is 1, 1, 1. So you put like this, and you determine the value of the determinant. So that will give the area of the triangle. For example, so the three vertices of a triangle are 0, 0, 1, 2, 4, 3 அப்படின்னு வச்சுட்டா its area is given by half into, so what do you do? x1, x2, x3 we put as first column 0, 1, 4. Second column y1, y2, y3 which is 0, 2 and 3. Third column we put 1, 1, 1. So now we evaluate this determinant. So இப்போ நீங்க பார்த்தோனே இந்த determinant எப்படி evaluate பண்ணனும்னா row method யூஸ் பண்ணுங்க. ஏன்னா 0, 0 நீங்க மேல இருக்கிறதுனால, so use row method since it is first will vanish, second will vanish. So we have to simply take 1 into cofactor of that. So it is 1 into So again sign பார்த்துக்கணும். இதோட sign plus, இதோட sign minus, இதோட sign again plus. அப்படிங்கனால we can get plus 1 into 1 into 3 minus 4 into 2. So we get minus 5 by 2. So area of the triangle is the absolute value of that. So which is 5 by 2 here. Okay. There is one more concept here, which is singular and non-singular matrices. Okay. So a square matrix is said to be singular if its determinant is 0, and non-singular if the determinant is not equal to 0. So we can do a simple example here. Determine the values of A and B so that the following matrices are singular. Okay. So in the matrix 7, 3, minus 2, A in கொடுத்திருக்காங்க. Suppose this is, it's given that this is a singular matrix. Okay. So then find the value of A. So how do you do that? So we simply expand this 7, 3, minus 2A. If you expand it, it becomes 7A minus 6. That is 7A plus 6. So since it is a singular determinant, so its value singular matrix, so its determinant is 0. So another 7A plus 6 equal to 0. That means 7A equal to minus 6, or A equal to minus 6 by 7. Right. So I think I've been able to cover it pretty fast today. So 7:30 முடிச்சாச்சு எல்லாத்தையும். So these are all the concepts. I just explained this with some examples. Okay. So நீங்க இத பத்தி கொஞ்சம் படிக்கணும். Okay. And try to do some more problems. So you know, the success in IIT or competitive exams is going to be purely based on your understanding. Okay. So not just by if you're simply solving some problems which is given in the book. That will not help. Okay. You should be able to solve any new problem. So நீங்களா think பண்ணி to try to do a few problems. Next week we will devote to fully problems on determinants. Okay, we will take some 8 or 10 problems. Okay, so I'll try to give some tougher problems also. Okay, so you come prepared. The chapter nalla படிச்சிட்டு கொஞ்சம் try பண்ணிட்டு நீங்களா கொஞ்சம் problems எல்லாம் போட்டு try பண்ணிட்டு உங்க respective booksலயே இருக்கு. So you come prepared. Next week we will work on problems. Yes, Keshav. Hi.
Yeah, thank you, Radha.